a speed of light 3 times 10 raised to the power 8 meter per second. This is again your YouTube content creator, your social media influencer, and a small, take note, small YouTuber. Okay, thank you so much for all my friends who really watched my videos, uploaded videos in YT. My revenues are rising. Okay, I can now afford to buy coffee, rice, fish, vegetables, fruits when I retired in my work in the future. Really? Okay, after the contract of 5 years, I'd sign NYT. Something like that. Okay, so that it will accumulate more there. Okay, now going back to the topic. Thank you so much, guys, really, for trusting my capabilities and my talents in doing this, substantial acts of sharing academic information to all of you guys. Okay, now the topic now is all about, again, I love this topic. Okay, it's gonna be all about elements, atomic masses, and atomic weight. Okay, as our basis in the calculations of the molecular weight, molecular mass, and the molar mass, and we can relate that also to the mass number. Now I have to differentiate what is the difference between the mass number and the molecular weight. So there is also a distinction or a difference. Okay.
The Bluetooth device is ready to pair.
Actually, there's a distinction. Distinction is not only mean award, reward. It's also meaning a difference. That's why it's called distinction, because you have difference with others. You receive the awards, top 1, top 2, top number 3. So you have graduate with distinction. But the definition of the distinction is really the difference. Okay? Like that. You get the point. So what is the distinction or the difference of mass number and atomic number? Mass number, okay. Mass number, molecular weight, ganon, okay. Like this. Okay. Because who knows in the future also, the question will say, calculate the mass of this compound, unknown compound, blah, 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 so and so, and the given is only the mass number. How can you do that? Okay, so it will trick you out. Okay, so meaning to say the mass number is just equal to molecular weight, molecular mass, and the molar mass. Okay, so these terms are parallel with each other or tantamount with each other. Okay, molecular or molar mass or similar. Okay. Okay, parallelism or parallelism of things means similarity. Okay, you get the point. Okay, so the mass number only difference, it don't have a unit. For example, if I have 238 is the mass number of uranium, radioactive element found in actinide series in the periodic table. Okay, uranium is also the heaviest element. Okay, like this. So uranium has a 238 mass number. This is also the same figure with the molecular weight and the molar mass and the molecular mass, but have unit. So this is now 238 gram per atom. Okay, some books says 238 gram per mole. It's just okay, but I preferred atom because this is only one, uranium. Because if you speak about moles, molecules, it's more on the compound situation, compound properties, diba? Okay, something like that. So I'm referring to the most precise of how to say things. Okay, like that. So that's gram atom. But I'm not saying it's wrong. I'm just saying precise of doing it, because some books really show gram per mole, even though that's an element. Carbon, what is the atomic weight of carbon? Some books also will say molecular weight of carbon, but actually that is not molecular because that is only one carbon, that is not a compound. You will say atomic weight, not molecular weight. You get the point? Because molecules having so many elements banded together. Okay, so the technicalities are really not good or not perfect. So you should be extra careful also how to use the terms. Okay, something like that. So uranium 238 is the mass number, and the molar mass is 238 gram per atom, the molecular mass is 238 gram per atom, and the molecular weight is 238 gram per atom. Meaning to say, molecular mass, molar mass, and molecular weight are just the same in chemistry. Okay? Erase. Nakakaloka. Diba? Ganon. So, siya yung mahitabo mga palangga. Okay? Now, we go back to this. I love this. Nakakaloka. Okay. So, basic formulas. Okay? Basic formulas. Okay, basic formulas. Okay. Okay, we go back to elementary particles before understanding very well. So we will see having the mass number. We need to scrutinize the differentiation or the difference of this terminology so that we can understand really. Okay, so mass number, atomic mass. Okay, like that. And the molar mass. Nakakaloka. Diba? Now, if I will say, for example, carbon. What is the mass of the carbon? Now, I'll ask you, Uy, Sotero, what is the mass of the carbon? Okay? Then I will answer to him, 12. I will never do that. Because 12 is not the mass. You get the point? It could either be an atomic mass or a mass number of that carbon. So I need to determine the atom first. So that if I will multiply that with the atom as my basis of calculation, it will become now the regular mass, the G only, gram. Okay, so Sotero, what is the mass of carbon? I cannot answer. Give me the number of atoms and I will show you the number of mass of carbon. Things like that, okay? So that's an intelligent answer for that particular tricky question, right? Okay, so I have the carbon here first. Carbon, okay. The atomic mass of carbon is 12 gram per atom. The mass number is 12 point something, the same. Okay, like that. And the mass is unknown. Of course, there's no molar mass because this is not a compound. And things like that, right? So I can easily differentiate. There's no mass, question, but there is a mass number. There's atomic mass. We don't have also the molar mass because molar mass is not the same as atomic mass when we are referring to an element only. If this is a compound, then bingo, we can have a molar mass, molecular weight, and a molecular mass. Any questions so far, mga palangga? Nothing. Okay, proceed. Okay, now, if we will try to force the mass for that particular question before, I will have a basis of calculation. For example, I will treat, my basis of calculation is 1 atom, 2 atoms, 3 atoms. Then I can have the mass of carbon. We're having the atomic mass. So, I will answer, give me the basis. I will say 2 atoms. So I will say 12 gram atoms times 2 atoms cancels the atoms. I have 24 grams of carbon. I can show you to now. Oh, I have 24 grams of atoms, but show me the number of atoms first. But if we will try to treat that generally, having the basis of calculation as really standard, which is the one atom, so he should revise his question. He will say like this, Sotero, what is the gram, what is the mass of the carbon if we have 1 atom? See, that is the correct question. But if you will just say, Sotero, what is the mass of a carbon? I cannot answer unless you can give me the number of atoms. Okay? So if 1 atom is our basis of calculation, it will just become 12 grams. Okay? The same as the mass number, the same as the atomic mass, but differ in the unit, which is the gram. Get the point already? Okay, the same as the compound. So I will treat this as a compound also. Let's say carbon, let's react carbon to hydrogen. Let's have natural gas. What is a natural gas? Okay, this natural gas is a renewable source. This makes a country rich if you have large deposits of this. Okay, this is CH4. Okay, I tried to react the hydrogen and the carbon. Okay, you will say also again question. So to me, what is the mass of this methane or natural gas if we have 3 atoms. So, you have also wrong grammar because it's already a compound. You will never say like that. You will specify what atoms is that, for the hydrogen or for the carbon. So, you know, in chemistry technicalities, you will be particular for the term, for the data, for the figure, and the terminology. It's not enough to learn the mechanics, how to solve, or to learn the pattern, how it is being solved. You need to learn what is that all about, basing on the formulas, equations, theories, and concepts really. And then with a couple of memorization. Okay, and that's very clear. So I will revise my question. So Sotero, what is the mass of natural gas if you have 2 moles of natural gas? And that is acceptable because that is already a compound. And I can compute later on, right? So wait, so 2 moles, no. Ako siyang iyag-yag diri ari. Okay, for natural gas or methane, the mass is unknown. Question mark. Okay. What is the mass number of methane? Now, you can answer this or not. Mass number of methane. Guys, mass number, if you try to link it with a compound, is a wrong grammar in chemistry. Why? Because mass number is applicable only to element. Okay? So, it's neither the grams automatically and also the mass number. It's not. Okay, so I will put also question mark. Mass number is only applicable for a single element or a single metal, single non-metal. Okay, but compound, no, wrong grammar. Okay, so atomic mass, wrong also because this is compound, this is supposedly molecular mass, molar mass or molecular weight. Wrong grammar, wrong chemistry grammar. Okay, so question mark also. Then molar mass, so I have, so carbon 12 plus subscript 4 times the atomic weight or atomic mass of hydrogen, which is 1.008, like this. So it will become something to 16 point something. Calculator, please. Okay, I have to multiply the force transport of hydrogen. Okay, times 1.008 mga talaga is equal to times 12 is equal to, wait, I have, wait, 2 times 4 times 1.008. Review. If you take a very suspicious result, right? Plus 12 is equal to 16.032 mga palangga. Yes. 16.0432 is the molar mass of methane. 16.0432. This is now grams per mole, not grams per atom, because it is now compound. You get the point? So, mo na siya nagtabo. So, okay. Now, there's no mass number again with this compound. Okay? Unless you break that elements in a compound, there's a mass number individually. Okay? With the point. Now, going back to the question, Sir Sotero, what is the mass of methane if I have 2 moles of methane? And it's very easy. Okay, 2 moles of methane, okay, multiplied by the molar mass, 16.0432 grams per mole. So cancel the mole, this is your grams. Okay, so multiply, it's gonna be 38 something, right? So 38.043 something like that. This will be your mass, grams, if the question will have a mole. You cannot answer if only like this. So Sotero, what is the gram of your methane? What is the mass of the methane? It's not wrong grammar really, if you're asking like that. You should have reference to consider. Moles, atoms, like that. Okay? You got the point. Meaning to say there's no magic. Okay, only God can do magic and miracles in our lives. Okay. You got the point. Ganon. Now, we go back to the basics of how to understand, okay, mass. So, going back to this, guys, since we know these elements have 3. Normally, the elementary particles, protons, electrons, and neutrons. Then we have to do the tabling. Tabling meaning to do the table. The act of creating and making a table is tabling. ing form. Okay, verb in English. So singing, you sing. Dancing, you dance. So you put ing. Because that's the act of doing a song. Or singing a song like that. Okay? So it's gonna also tabling. Okay, meaning to say I will do a table, creating tables here, so tabling. I explained because this is not common, but it can be through English grammar, tabling, okay? Not usually used in a sentence, right? But it can be because it follows the rule of English, right? Okay, so we have a table here. Okay, like this, nakakaloka. Okay, we have the mass. Okay, the mass, the charge. Okay, the mass, the charge, and the electrons. Okay, like this. Okay, the mass, the charge. Ganon. So I have here, okay, electrons. Okay, first row is the electron. Makita niyo mga palangga? Yes, makita. Okay, electron. Second will be the proton. The third will be the neutron. Okay, like that. For example, I have to put another column. Just to test our knowledge, I have to put molar mass in the third column. Things like this gas is criticality, meaning not limited to what is being discussed in our education when we are studying. We'll just put another in order to sharpen our brain cells. Get the point? And that's through research, reading, in your extra time, something like this. You get the point? Okay, so like this. Electrons, what is the mass of an electron? Let's say, I cannot do that, Sotero. That's too difficult, too technical. Okay, what is the charge of an electron? And this can be answered right away because it's very common in our elementary level of education. The charge of an electron is always negative. So put negative. Then put the figure. Okay, negative 1. Okay, now what is the molar mass of electron? It sounds crazy. Okay, that's question mark. Molar mass is a room grammar for electron because molar mass is applicable only in compound. So we eliminate this another column. I'm just testing you know, the ability to think. Okay, so molar mass is not needed in the tabling. Okay, like that. Only the mass and the charge. So based on my research, okay, a long time ago, so the mass of an electron is 9.109 times 10 to the negative 31, and the unit is kilogram. Okay, so imagine how light the electrons really is. Okay, times 10 to the negative 31. For example, if I have nitrogen, okay, nitrogen here, okay, nitrogen. Nitrogen is, you know, is very, very important in our atmosphere because this is 79% by volume. Okay, volume percent that God gave to us freely in order for us to survive. That's air in the atmosphere, plus the oxygen, 21% also by volume. God gave to us freely, okay, nitrogen. Aside from that, nitrogen also is inert gas. Inert gas. What do you mean by inert gas? This is unreactive and non-flammable. So in short, nitrogen gas cylinders are flammable because this is an inert gas. Or like that. So if we have nitrogen gas plus oxygen gas in our atmosphere, what will be happening here? This oxygen is very active to other gases. So this oxygen can really react to other gases. The contamination is very strong. And then some of the molecules of this oxygen will be replaced by other elements or other gases in the atmosphere. That's why it will become 19, 20.8, 20.7, 20.6. The 21% regular that God gave to us will decrease. But take note, the nitrogen is fixed to 79. Okay, because this is not reactive. But this not will react to others. Okay, will not reactive. Okay, now like this. So it's gonna be 9.10 Now we draw the electron's outermost shell of the nitrogen. Ganon. This is the outermost shell. Okay. What do you say, Sotero? What does that mean? You mean by outermost shell? Okay. Outermost shell, like that. Scrutinize the terminology. Okay. Outermost shell, so that we will understand. is also the same as shell alone without putting outermost. Okay? This is also what we call energy level. Okay? Or this is what we call only level. Okay? So these terms can be used interchangeably in different questions in the future. Okay? In science quiz bowls, science examinations, board examinations, or whatever. Okay? Like that's the outermost shell, the energy level, the level, or the principal quantum number. Okay? Principal quantum number. So this is also denoted as N. The same as small letter n, the same as the unit of the amount of substance, letter n also, in the expression of the concentrations topic in different solutions and lectures in general chemistry lecture, the number of moles, M-O-L-E-S. So the same here also in this topic. And you have to be extra careful, apply that in the present topic accordingly. Okay, because we are here, so let's adopt that here. Okay, that small letter n is our principal quantum number. For example, if I have nitrogen, determine the electrons of nitrogen. I said 9.10 times 10 to the negative 31 kilogram is the mass of the electrons. But that is still the mass of one electron, not for nitrogen. Now, if we can have the electrons of nitrogen, then we can compute easily the kilograms of electrons found in nitrogen. Okay, now go to the nitrogen. Okay, so in our memorization, in our, if you are science profession, or let's say BS chemistry, BS chemical engineering, or whatever, courses that have too much chemistry or higher chemistries. So we are very, very strong, we have a very, very strong foundation regarding elements, reactions, substances, name it, gases, solids, liquids, and everything, so that we can really understand the processes. Physical and chemical processes, okay? Chemical reactions, physical, whatever. Okay, now, going back to nitrogen, okay? Nitrogen, mga palangga, what's this? There's a Sotero, what's this in nitrogen? So nitrogen and phosphorus belong to group 5A. Okay, this 5 is also the valence electrons in the outermost shell. Okay, now I have to draw na. Okay, talaga, okay. Oh, muna siya, ganon. Now, take note yung nitrogen, mga palangga. The nitrogen is in the second level. Only. And I have to prove that later, ha? Second level lang ang nitrogen. Because nitrogen occupied in the second row of the periodic table. Because as I said earlier, during the discussion of the properties of the periodic table, the energy level would represent the period and the row of that particular periodic table. Since nitrogen occupied in the second row, we're in the period. So meaning to say, we have two energy levels only in terms of nitrogen. Okay, something like that. And this last circle is the energy level, is what we call the outermost shell of nitrogen. Okay, ganon. Since I have here 5 valence electrons, meaning to say these 5 electrons occupy in the last energy level of the nitrogen. So I put 1, 2, 3, 4, 5 in the outermost shell of nitrogen, in the second energy level of nitrogen. Okay, now I said a while ago that it is 9.109 times 10 to the negative 32. It's very easy. Okay, you have to multiply this by 5. 1, 2, 3, 4, 5. Right? Okay, you will say. Okay, 9.10 times 10 to the negative 31 kilogram of electron, right? Okay, how many electrons here in the outermost shell is 5, like that. So let's say 5 electrons, okay, and then per atom, like that. So cancels the electrons, what will be left is atom. You can solve for atom, okay? And then you can also 2 grams, if you relate that also with the nitrogen atomic mass. Okay, so I will say, okay, I'm gonna show guys, okay. 14 grams atom of nitrogen, okay. Then we already solve the atoms of nitrogen in terms of its electrons, which is 9.10 times 10 to the negative 31. Then we can cancel the atoms. Then we can have the kilogram later on. Okay, like that. Now, is this logical or valid? Is this logical valid that we say one atom is equals to the 5 electrons on our ratio, in our fraction? Is there a theory that relates to that? That's your question also. Because this is on the spot, my friend. I did not prepare this in front of you to discuss this all. Okay, this is on the spot. That's why I need to think, it's really this logical or not? If this is prepared, then I know already, don't need to ask you, right? So is this logical that one atom will occupy 5 electrons? So in this case, we might opt to take note the Avogadro number. Okay, Avogadro number is 6.023 times 10 to the 23 atom. Butang mo yung mga atom din, makakuha na ka. Tignan naman ka electrons. Okay, something like that. After that, you solve for the atom, yung atom, and you have the molecular weight grams per atom. Cancel the atom, you can compute for the grams of nitrogen, the mass of nitrogen, in terms of the mass of the electrons. Okay, because you know already how many electrons in the outermost shell of that nitrogen. Ganon. Okay, so that's why I told you it's very important to memorize or to familiarize the atomic mass, atomic weight of each element. Okay, that's it for nitrogen. And now for the proton. Ganon. Okay, proton has a charge of positive. Okay, positive. Okay, proton. Proton is also known as an atomic number. Take note. Okay? Proton means atomic number. So if I will say, I will say that radon, let's say, radon palagay, sorry, I need to issue an error statement before because I said radon is Rn, that's Ra. Okay? Sorry, because that's confusing. So we have also the radium, like that. Correct me if I'm wrong, mga palangga. Wait. Okay. Correct pala. Sorry, perfect. Rn pala talaga ang radon, okay? Because the word N signifies the radon. Radium is Ra, okay? So things like that, guys, you have to verify, ha? But the small things to consider because it's also not... For me, based on the actual confession, there's no such question like that in the board examination that will say, what is the symbol of blah, blah, blah? No, it's not because it's very easy, okay? It's not like that. So it's more on the calculation, and the theories, and the concepts like that. For example, 150 questions, you have to answer that, like that. But it's not like this. What is the formula, or what is the symbol of like this, like this? So it's a very minor thing for us, okay? You get the point? Okay, that's why I need to verify also. Okay? You get the point. So for the proton, the mass of the proton is 1.67 times 10 to the negative 27 kilogram. Take note, guys, the standard mass of these elementary particles, proton, neutrons, and electrons are kilograms. Okay, not grams. Then if the question will say how many grams did you have to convert, conversion factors na lang siya. Could it be English units, or SI, or metric system? Okay. Now we have the positive one for the proton, and for the neutrons, our charge is 0. Why? Why? Nakakaloka. Why? Okay. Later I will answer that why. Okay. And now the mass of the neutron is nearly the same as neutron. Why also? So many whys in our brain cells, right? An intelligent question. Why? Why, Delilah? Diba? Okay. 1.67 times 10 to the negative is nearly. Okay? So it's not perfect 1.67, but 1.65, 5.666. But in theory, it will just be summarized as equal. Okay? Like that. Now, if I have to refer the John Dalton atomic theory, this is an atom. Right? Okay. What is an atom? Okay. Things like this is very interesting, right? So, if you really are an instructor by profession, every word that comes from your mouth, you have to ask the students. And say, we go back to the atomic theory. By the way, what is an atom? You should collect quickly as you can so that the students can understand per terminology. Okay, so that they will be, extra careful with the future examinations. Then, you brief them properly. Then it's really a fulfillment in your part in the effective teaching or quality of education, something like that. Okay, now going back to this. Okay, so this is gonna be like this. This is an atom. Okay, the atom is the smallest particles in the nucleus. something like it, or the tiniest particles. Okay, like this. Okay, now this is the atom, and we have a nucleus here, another circle at the center, nucleus. Okay. By the way guys, mga palangga, particles generally inside the nucleus are what we call as nucleons. Also another theory, nucleons, N-U-C-L-O-N. The nucleus is also another thing, huh? This is only nucleons. Okay, there's a lot of terms to remember really in science. Okay, then we have, and this inside the nucleus, okay, so meaning to say, these protons and neutrons are nucleons inside the nucleus. Okay, the general term of these two. These protons and neutrons are combined inside the nucleus. Combined, bonded with each other. Okay, combined. Like, and these electrons are in the outer shell here, rotating. Okay, electrons, 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 like that, like rubber, chupa. The reason is it's very light, times 10 to the negative 31, of course. And then, as I said earlier, protons and neutrons are nearly equal, so they must be combined with each other. Okay, now, my question is, I will go back to my question. So, why the neutrons is equal to... The first question I raised is already answered. The neutrons having the same grams for proton because they are bonded inside the nucleus together. Normally, they will share the same mass, of course. Okay, now, why it will become zero for neutrons? Okay, because that is electrons plus protons is equal to neutrons. Okay, we prove this later on. Okay, electrons negative 1 plus proton 1, then neutrons is 0. Okay, so electrons plus protons is equals to neutrons. Okay, let's prove this. Maybe this will be wrong. Okay, we don't know yet. Okay, so negative 1 plus 1 is equal to 0. Now, if I have applied to an element, let's say, hindi na tayo lalayo, nitrogen. Okay, so nitrogen. How many electrons in nitrogen, mga palangga? So, question mark. Protons. Protons is very easy because this is the atomic number only. Okay, so nitrogen proton is 7. So 7 is our atomic number, right? So we have now the protons. Okay, but we don't have the electrons, and we have also don't know the neutrons. How can we compute for the neutrons and electrons? Now, we will consider the mass number. Okay, mass number of nitrogen. Mass number is equals to protons plus neutrons. Ganon. And mass number, as I told you in my previous lecture, is just equal to the atomic mass, but no unit. Only number. So it's called mass number. Take this seriously. It's number, meaning no unit. Mass number. Okay? This is only the type of number. The mass is an adjective referring to a number. So the mass, the word mass there is just used to describe the number. Okay, that's mass number. It doesn't have to have a unit. Okay, so the last identification is the last word. Okay, for example, I will say Sotero. For example, I will have an example on the spot. Kasi okay, instructor. So clever instructor. So that clever is a description of an instructor. It was used as an adjective describing that kind of instructor. The same also with mass number. That number is a mass describing the number. Mean to say no unit. Okay, like that. So the mass number is just equal to the atomic mass of the nitrogen, in which we memorize that completely as 14, right? 14 grams per atom. So the mass number is also 14, right? So then if you have to verify that very well in the periodic table, so that's very, very perfectly correct. Okay, so it's 14. Now, you have now the mass number, 14, mga palangga, and then you have the atomic number, okay, the atomic number of nitrogen, okay, which is equal to 7, okay. Now you can solve for the neutrons, okay, by math. Okay, math. Basic math. Okay, neutrons is equals to 14 minus 7. Means transpose, chuba, chuchu. So 14 minus 7 is 7. You have now neutrons of 7. Substitute that here. You can solve electrons. So electrons is equals to, let's say, neutrons 7 minus the protons. The protons is the atomic number, which is equal to 7. Then bingo, your electrons is 0. Meaning to say, we are valid in our first assumption that electrons plus proton is equal to the neutron. Really just now discovered. Nakakaloka, di ba? Day to day natin about, we have new things to discover. I don't memorize this formula, electron plus proton is equals to neutrons, like that. Really. But through the table, I created my own definition just now. Okay. We are very, very observant through the table. See, if I have a neutron 0, then if you add the 2, it will become 0. So I have electron plus proton is equals to neutron, so 0 siya. Then we have to adjust, and then, so meaning to say, electron plus proton is equals to neutron is also a formula how to solve the neutron. Because all I know, really, the formula of neutron is based only for the mass number, which mass number is also proton plus neutron. Then neutron is equal to the mass number minus proton. I thought this is the only formula for the neutrons. Have also this one through the table just now discovered by myself. Though the others already discovered, but for me now only discovered. Okay, like the electrons plus proton is equal to the neutrons. Oh my gosh. Okay, it's perfectly correct because both are 0. Okay, now. What is the formula of a charge? So, a charge. So, you'll see proton plus electron. So, this is also equal pala. I memorized, but the charge is here. Here the table, I memorized based on the 0. Okay? Okay. Diara. Okay, I memorized this formula. Charge is equals to proton plus electron. This 0 is already a charge for neutron. That's why it will be the same thing pala siya. Okay, so things like this, right? Very interesting. You can discover, different ways how to attack the particular, topic. Okay, any questions so far? Okay. Now, for example, if I have sodium chloride and the sodium has a -1 electron and has a proton positive, then it will become 0. So that is a neutral compound because neutron is 0. Anything that's a neutron equal to 0, meaning that is a neutral compound or neutral element. Okay, for example, like this. This topic also is very important in obtaining the oxidation number, oxidation state in the redox equation. Reduction and oxidation chemical process. Ganon. Diba? Okay, ganon siya. Okay, so for example, I have pure substance. Okay guys, when we mean a pure substance, doesn't mean a solo flight element, it doesn't matter whatever it is. Okay, for example, if I have gold, oh my gosh. Gold makes us rich. Okay, gold. What is the symbol of gold? Gold is AU from aurium. Greek word for gold, aurium. So meaning to say aurium, you have also aureus or auric in the naming, right? Of the chemical formula. You get, this is also the gold. Okay, like that. Okay, so the gold is AU with an atomic mass of 187 gram per atom. So just memorize this very quickly because gold is very popular. At least you know, the atomic weight and atomic mass of gold is 197. Ganon. Diba? It's an advantage really to memorize some important points. Okay? Gram atom, like that. Okay, ganon siya. That's gold. Okay? So, that is a pure substance gold. Oh, ganon. Meaning naturally occurring. Naturally occurring in the Earth's crust. Oh, Earth's crust meaning underground, the soil or the land. If you dig deeper like that through mining operations or let's say drilling operations, then you can get gold somewhere along the way. That is only if the land is noted to have gold deposits. Okay, it depends on the study, on the exploration. Okay, but if that is known not to contain gold, then you don't have to start. Because according to the documentation, that area and that country has no gold in there. So why you should force yourself to dig? In fact, there's no gold deposits noted based on the records. So you have also to think before doing such things, which requires money, effort, resources. So it will be wasted after all. Okay, it's common sense, right? So we need to, before digging, we have already all the documentation proven to be true and correct so that we can really get that gold somewhere else in the underground. Okay, so that is the atomic mass of gold. Ganon. Okay, 197 joules. Okay, does gold react to nonmetals? Okay, I will ask you. It will react to nonmetals. Yes, but not so many. For example, oxygen. Oxygen is a nonmetal, right? It's a gas. We have also auric oxide. Diba? So let's try to do it for the very, very first time in my entire life. So auric oxide. We don't have this kind of component that was in, in elementary, in high school. Just now, I discovered. So auric oxide. Okay, let's do the theory for this. Auric is positive 3, like there are two charges of auric or the Au or the gold. It could be positive 3 or positive 5, right? Ganon. You get the point, mga palangga? Ganon. So what is the common for the gold? Then you have to choose. Could either be the 3 or the 5 or something like that. For oxygen, no problem, only 2, negative 2. Okay. So let's just consider the 3 to make it safe. Okay, just like the aluminum, something like that, right? Or whatever. Okay, just like the gold, the copper, like that, the silver, the gold. Okay, Ag, As, astatin, ganon. O, diba? So, let's say 3 lang atong i-consider, mga palangga. 3, okay. Okay, because there are elements, guys, or metals have 2 charges, and we found difficulty which among the charges are stable. Okay, unless we do the experimentation in the laboratory, which are them have a stable charge. But based on the theory, already choose the more stable. And for the purpose only for the discussion, I may use 3. Okay, whether it's proven or not, the most stable or not. For the purpose only of understanding. So since we use Au positive 3 charge. Okay. Positive 3. For example only, okay? Let's say to make it safe-free, hypothetical. Okay, meaning because if we try to be sure and then what if it's not sure, so it's already a shame. So only, it's hypothetical. Since I'm not really that sure what is the charge of this gold. O, diba? Ganon. And then we have the oxygen. Okay, oxygen sure, negative 2. Okay, now, statements. It needs 3 oxygen atom to completely neutralize the gold. So I have to say oxygen negative 2 plus oxygen negative 2 plus oxygen negative 2. So we have 3 oxygen negative 2. Okay. Now, it needs 2 gold. Okay. It needs 3. Okay. For oxygen. It needs 2 for the gold. So we have Au, okay, plus Au. Ganon. Okay, count is equals to 2 Au. Ganon. Now, predict the product in adding gold plus oxygen to become auric oxide. Because you choose auric, not the aurus. Example only. Okay, so auric oxide. Okay, now put the oxygen. There are 3 oxygen, put in the subscript. Ganon. And then for the auric 2, put the auric 2. We have Au2O3 as our formula for auric oxide. Okay, like that. Things like that. Okay, you should be extra careful. But others only changing the charges. Reversing the charges, no na siya. But it's better to understand in this way, Okay, like that. For the purpose of easy computation, you can have that also, that reverse the charge. Okay, for the purpose of discussion lang. Okay, you get the point. Mga palangga kong hitad. Okay, mo na siya. O, diba? Any questions so far for this? Nothing? Okay, I have to stop this vlog, and we will rest for a while because I have to eat my dinner. Okay, thank you so much for listening for this specific vlog about the, atomic mass, atomic weight, all about periodic trends or whatever. You can like, you can comment, you can share this video if you want also. Then you can subscribe my YT channel if you want. If you are not subscribing at my YT channel, and then you can click the notification bell for some newest updates and then turn on voice. Bye-bye. God bless everybody. Ganon. Kaloka. Naluloka si, Junjun. Naluloka.